Hi, good evening, my dear student. Yes, another one greatest theorems of an order. In this theorem, we are going to deal with very clear greatest common divisor, GCD. It means HCF and LCM. How you are going to find out? Here, GCD means greatest common divisor of one thing, and another one is the prime, relative prime numbers are. When you are going to deal with P and N are the relative prime numbers. So which numbers is there? For example, you are going to consider Pn is which is the greatest common divisor. It is only 1. Then expression of the value. So clearly we are going to defining the one theorems is there. If the conditions are most important, let us discuss first the theorems, how they are going to define and how to prove that. So each steps are most important. What they are going to define? Order of a to the power of p to the power of n, law of exponent, and e to the power of y, and some linear equations m of x plus or p of x plus q of y. In this one we are expressed for the a to the power 1. You can consider it is a 1. Then these expressions are there here in this theorem. Let us discuss first one by one how we are going to take values. So each equations are clearly most important. Theorem: if order of a is equal to n, if order of a is equal to n, and p is relatively prime to n, it means that is p of n is equal to 1. Greatest common GCD they are asking. Then order of a to the power p is equal to n. It is equal to order of a. Suppose the conditions are very important. Already I told to you. Suppose order of a to the power m. So this expression already order is there. This product is there. It convert the formula. So order of p to the power m is equal to equation 1. Let us consider. This is the theorem. This theorem I can convert to the formula. Right. So by the data order of a is equal to n. So this expression formula always we are going to think like that, a n to the e. So order of a is equal to n, that reverse case, right? So then we are going to take order of n and express. So in this one I can multiply both powers p. So here order of p to the power n is equal to e. So this order of p is less than or equal to n. By the one of the greatest theorems we have proved that. So this means what? M. This is equation number 2. So next we are going to prove that p is relatively prime to n. They are very close. Prime means what? Which is divisible by itself. Prime number means the number which divides itself. It is called the prime number. So by the way of discussion, here p of 1, greatest common divisor p and n is 1. So p of n is equal to 1. So this equation, linear format, one of the greatest equations of the our mathematics, p of x plus n of y is equal to 1 for some integers x and y. Actually they are considered k and so p and q. But here they are different values. No problem. That situation on we are going to consider. P of x plus n of y is equal to 1 for some integer x and y. So what we are a to the power 1. So this means what? 1. 1 means p of x plus p. So this is the law of exponent. I am expressing the form of powers. So that separate, that we are going to take a separate value. So a to the power of p of x, the bases are same, then powers are adding. This is the reverse case, the law of exponent. So one of the greatest law of exponent. So I hope a to the power of n is equal to e, identity we prove here. So that expression. So any identity power itself identity. So a to the power, that means what? A to the power of p of x. So here a to the power of p of. So this equation I can multiply both sides in the power integral m. So here then m get inside, x goes to that side. So here law of exponent only for the powers interchanges. So that one, so I can take multiply mx or xm. So this it means m go to inside and x I can take out, because the reason I am going to express for the formula. So the way of this one, right? I am going to way of this one. So this means we are going to express m. So here totally it is identity. That is means what? I hope to the power of m is equal to e. Look at this one, I can write e. So this any power of x itself e. So a to the power of m e. So this finish. So look at this one, order of m is equal to less than equal to m. This is the third equation condition. This is the n. So by the way of equation 1 and 2, here look at by the equation this one and here this one. M is less than equal to n is by the condition of this one, m is equal to n. By the way of, we are going to prove that a biggest theorems. So that is called the order of a is equal to n and p is relative to prime to n, p of n. The greatest common divisor is there, GCD is there, and relatively prime numbers are there. Each and every theorems are very clearly, they have statement and equations. By the way, we have proved that, hence this is the required equation. In the next video, I am going to defining cyclic group and another theorems are there. So discuss in the next video. Thank you so much. I will continue the next video.